Hi everyone, I'm going to be going over problem 7 from problem set 2. If you're in my discussion section, the second discussion section, we went over this and I wasn't happy with how I explained it, so we're giving it another shot. To start with, we're going to go over the setup for the problem, right? We have a bypass Tomasulo machine, we have one functional unit per operation. All functional units are unpipelined, which means they cannot accept more than one instruction at a time. The register file has infinite read ports, but only one write port. So only one instruction can write back in a cycle, and there is only one common data bus. There's a fetch, a decode, and a write back stage to our pipeline, in addition to the reservation station stage and the execute stage. In the case of a conflict, the oldest instruction is scheduled first. So older instructions, if they want to write back at the same time as a younger instruction, they're allowed to write back first. Then there's a note on what a fully bypassed Tomasulo machine is, which means we can bypass the reservation station if our dependencies are already resolved. So you're asked to find the latencies of the functional units, and then on top of that, complete the timing diagram. We're going to be looking at the timing diagram, since through this, you'll get the latencies of the functional units. So I'm not going to do the whole timing diagram, but we will be going over at least a little bit of it to the point where I think I've showed enough for you to figure out the rest of it. So let's start with the first instruction. And the way I like to solve these problems is to resolve a clock cycle and then move on to the next one. So I look down and then I look across. So cycle 1, we fetch the first instruction. That's all we're going to do. Cycle 2, we're going to decode this. Since this instruction is being decoded, our fetch unit is free for the next instruction. In cycle 3, all the dependencies are resolved for this instruction, so we'll bypass the reservation station and begin execution. Since we're beginning execution, we're allowed to decode this instruction, and since we're decoding this instruction, the second instruction, we're allowed to fetch the third instruction. In the fourth cycle, we'll continue executing our add, and we will check to see, can we execute the multiply? So since the first instruction is writing to R0, R0 is in flight, thus the multiply must wait in a reservation station. Since the multiply is in a reservation station, we are able to decode the third instruction. Since the third instruction has moved to the decode stage, we are able to fetch the fourth instruction. On to the fifth clock cycle, we'll continue executing our add, of course. Our add is still executing, so we must take another cycle in the reservation station for the multiply. Now the divide has a choice. Are we able to go straight to the execution unit, or must we stay in a reservation station? So we're dependent on R1, we're dependent on R2. R1 and R2 are both valid at the time, so we can bypass the reservation station and begin executing immediately. Moving the divide instruction to the execution unit, we can now decode the next multiply instruction. And since this instruction is being decoded, we can fetch the next instruction. On to cycle 6, we continue executing our add instruction. We are still in the reservation station for the multiply instruction. Since we have not written it back yet, it is not on the common data bus yet. For the divide instruction, we're going to continue executing. And then for the multiply functional unit, we have a choice. Are we going to a reservation station, in this case causing a structural hazard with this, or can we go bypass the reservation station? So you'll notice we're dependent on R3, we're dependent on R2, and R3 and R2 are not in flight in any of the previous instructions, right? So we'll go ahead and take the execution unit for the multiply. Since the multiply has moved out of the decode stage and into the execute stage, we're allowed to decode this instruction. And since this instruction has moved to the decode stage, we're allowed to fetch the next instruction. All right, on to clock cycle 7. Our first instruction is finally going to write back. While we're writing back, we'll look at what other instructions are going on, right? So since we are writing in this stage, no other instructions can write back. So what does that mean for our the instructions already in the pipeline? So for this divide, in this clock cycle, we are either executing or we are stalling. We cannot be certain which one it is. For the second instruction, for the second multiply instruction, we are either executing or we are stalling. We're not sure which one it is. So this execute or stall is caused by a structural hazard on the register file. Since there is only one write port, we are unsure if divide is still executing, in which case it has a 3-cycle latency, or if it's done executing, it wants to write back, but since this instruction is older than it, it gets scheduled preferentially, right? So these two instructions we are uncertain of at this time. Now, in this cycle, we're writing back the result of R0. The multiplier will pick up R0 in the reservation station, but it cannot begin executing because this instruction is currently clogging the execution unit. So our second instruction must stay in the reservation station while our fourth instruction still is taking up the execution unit. So moving on to this instruction right here, the fifth instruction, sorry. So moving on to the fifth instruction, we have some dependencies. So R1 is in flight still. So we'll check, has R1 been written back yet? It has not, so what do we do? For the divide, we will go to a reservation station. So the divide will go to a reservation station, and then this divide, since we freed up decode, this divide is allowed to go to decode, and since this divide is allowed to go to decode, this addition is allowed to be fetched. So, sorry for the break in the recording, but I think this is where I'll leave off. We sort of went over, a structural hazard occurring with the write. We went over scheduling preferentially, for the decode and whatnot. I'll leave the remainder of the cycles up to you to resolve how do they work. So I'm much more happy with this explanation, and I think this has pretty much cleared it up, if not, solved the problem for you. So if you have any further questions resolving, what to continue, what goes on here, etc., feel free to email me with them or post them on Piazza and we'll get back to you. And then other than that, good luck with the problem set and good luck with exam 1.